Hey everybody. So today we're going to talk about vertical transformations of quadratic functions. Okay. We want to start with our parent function. Now remember, the parent function is that kind of starter function. That's the most basic quadratic function we can get. Okay. The parent function of a quadratic is y equals x squared. Okay. We could also see it as f of x equals x squared if it is in function notation. Okay? All right. So there's some things that we want to know about the quadratic function. There's some patterns in here that will help us graph it much easier. Okay? And so we're going to talk a little bit about that, and then we'll talk about what happens when we have a vertical shift. Okay? So for our first transformation, for our parent function, when we look at the table for a parent function, and you can put this in your calculator, if you go into y1 and just type in x squared, you'll have your parent function. So here's my x, here's my f of x. I'm just going to start with -3, -1, 0, 1, 2, 3. Now, the parent function is x squared. That means I'm going to take my x, I'm going to square it. So -3 squared is a +9. -2 squared is a +4. -1 squared is a +1. 0, and then 1, 4, 9. Okay? So there's our parent function. I'm going to go ahead and graph it over here on this graph, because we always want to start with the parent function, especially if we're going to be comparing things. Okay? And you notice I only did the right side. Well, from our key features lesson yesterday, you know that it mirrors around the axis of symmetry. So even if you only know one side, you can get the other side. Okay, we're going to go ahead and draw in our parabola. Okay, all right. So there's our parent function. Now, there's some patterns here that we want to talk about. A very important pattern that we want to talk about real quick on a parent function. Okay? If we look at our y values, the change in our y values, okay? First of all, here's my vertex here at 0, 0. Okay, this is my vertex. From my vertex, if I go in either direction, I have a change of 1. And then if I go again, I have a change of 3. From 1 to 4, I get 3. And then again, if I go back from 4 to 9, it goes up 5. Okay? So if I just look at that pattern from my vertex on a basic parabola, from my vertex, if I go over 1, I'm going to go up 1, and then over 1 and up 3, and then over 1 and up 5. So my pattern is going to keep going like that. What you aren't seeing on the table, if I keep going, when x is -4 or +4, the y value is going to be 16, because it's going to go up 7. And then at +5 and -5, it'll be 25, because it goes up 9 from there. Okay? So we're going to start with what we have here. This is our parent function. Okay? Our g of x function, we are going to, I'm going to rewrite my parent function here. And then we're going to put our g of x function next to it, okay? So our parent function, again, we started with -3, -2, -1, we've got 1, 0, 0, 1, 1, 2, 4, 3, 9. Okay, there's our parent function. All right. Now, g of x says I take x squared and then subtract 4. Okay? So 9 minus 4, I'm going to get 5. 4 minus 4, I get 0. 1 minus 4, oops. 1 minus 4, we get -3. 0 minus 4 is -4. 1 minus 4, 4 minus 4, 9 minus 4. Okay? So x squared and then -4. If I graph this, okay, my vertex is still at, my vertex here was at 0, 0. Now it's going to be at 0, -4. Okay, so I'm going to move that down here. 0, -4. My axis of symmetry is not changing. It's still at 0, at x equals 0. But my points are being shifted down. Like these points right here got shifted down 4. Okay? And then at, what is it? 2, 4, so, or sorry, at 2, 0, and at -2, 0, okay? That point got shifted down 4 units. And then at 3, 5, and -3, 5. This point got shifted down 4 units. Okay? So we connect our points. Okay? There's our g of x. To get from our f of x to our g of x, to get from our parent function to the new function, we shifted all our points down 4. That's what that -4 means. Okay? Back when we did linear functions and we shifted vertically, and we changed the y-intercept, it shifted the line up or down based on what the new y-intercept is. Same thing here. We're shifting that parabola up or down based on what we're subtracting. Okay, this is the D part of our transformation form of a quadratic. Okay, so I didn't talk about that a minute ago. I should have. I apologize. Y equals A times BX minus C all squared plus D. Today we're just focusing on the D part. Okay? This is the part we're talking about today. If it is a plus D, we're going to shift up. If it is a minus D, we're going to shift down. Okay? Simple as that. We're just up or down. Okay? We're not going to mess with any of the others in this video. Okay? So, just shifting up or down. Again, our domain, no situation to it. X equals all real numbers. Okay? For our range, okay? With our range, again, we're looking at our minimum, okay? Our y is going to be greater than or equal to -4 because that is the minimum of the quadratic. All right, let's flip on over to the next page, page 8. Okay? All right. Again, we're going to start with our parent function. We're going to graph our parent function first, just so we can see see our changes, okay? So 2, 4, and 3, 9, okay. These are the same points that we've been using for all of our parent functions because it's still the parent function. Okay? All right. And I'm going to go ahead and do my table again. It just helps to make it a little bit easier to see what's happening. So our parent function, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. All right. This time for g of x, we're taking f of x and we're going to add 3. Okay. Now this is that function notation form. Remember, f of x is x squared. So it's still a quadratic. It's just saying we're taking whatever that f of x function is, we're going to add 3. Okay? So if my f of x is 9, I'm going to add 3 and get 12. If for 4, I'm going to add 3 and get 7. I'm going to 1, add 3 and get 4. 0, add 3 and get 3. And then they go backwards. Okay? All right. And we can graph that. Now, we're not going to be able to graph the -312 or the +312, but we could graph the rest of them. Okay? So 0, 3, 1, 4, and -1, 4, 2, 7, and -2, 7. Okay, and there's our new parabola. Okay, there's our g of x. Now, each of these points shifted up 3 from the parent function. So, whichever 3 points, whichever points you want to look at from the parent function, when we just shove them up 3 units, we get this new g of x function. Okay? How does the vertical change affect the domain? It doesn't. Your domain is still going to be all real numbers. Okay? So there is no effect. Okay? How does the vertical change affect the range? Well, that's where, it's going to change. Your minimum or maximum will now be whatever the new vertical change is. Okay? So the range, min or max, is same as the vertical change. All right. So again, over here, my domain, x equals all real numbers. For my range, for my parent function, f of x, my range is greater than or equal to 0. But for my new function, g of x, my range is greater than or equal to 3. Okay? All right. Let's look at doing some changes when, we already have something there. If we want to describe the change, how the graph changes from the parent function, f of x equals x squared, then we need to write the equation for the function below. Okay. Remember, the parent function starts at 0, 0. I'm going to draw my parent function in here just so we have comparison. Okay, so here's my parent function, and I'm going to kind of dash that one in there. All right. So from my parent function, it actually dropped down 2 units. Okay. So we want to say that it shifted down 2 units. Okay, shift down 2. Now my new equation, because it's the parabola, it is x squared, and then we went down 2, so minus 2. If we write it in that function notation format, in f of x format, it's going to be g of x equals f of x minus 2. Okay? So there's our new equations. For b, it says to translate the function below down 6 units and then write the new equation and identify our new vertex. You notice that is not our parent function. On this one, we're starting with a non-parent function, and we're going to shift that one around. So we're going to take this function that's here and go down 6 units. So 1, 2, hold on. We're going to take that one, go down 6 units. 1, 2, 3, 4, 5, 6. Down here. Okay? All right. So here we go. This is really all I'm worried about, but I'm going to go ahead and put my other points in here. 1, 2, 3. And then 1, 2, 3, 4, 5. Here are my other points. Okay. So my new vertex is down here at 0, -3, which means my new equation is x squared minus 3. Okay. Or f of x minus 6. Okay. If this one is f of x, our original one, then we can write this as f of x minus 6 because we went down 6 units. Okay, for my on-level classes, your assignment for vertical changes is on pages 9 and 10. And for my pre-AP classes, you get to enjoy one more video before you get to your assignment. All right, you're going to have to watch the 8-2 video on horizontal changes. All right, guys, have a great day, and I will talk to you later. Bye.